Hello, everyone. My name is Mo Kadora. I'm a graduate student in the Master of Science in Data Science program at the University of San Francisco. Today, I will be talking about my machine learning project on song genre prediction. My research question is, can we use a song's audio features to predict its genre? To answer this question, I obviously need data. I used Spotify data for 56,000 songs that had a total of 233,000 genre labels. Each song had 18 audio features, such as acousticness, loudness, and speechiness. The data came in a CSV with multiple rows for each song, one for each genre. I transformed the data so that there's only one row per song, and the target column is a list of genres. It'd be really hard to train a model on data where identical rows have different targets. Let's imagine for a second that each song only had one genre attributed to it. We would naturally want to use a multi-class classification algorithm. The two candidates I chose are random forest and k-nearest neighbors. So that would be the case for one class per song or one genre per song. How can we apply these same algorithms when the target is multiple genres? The strategy that I chose is one versus rest classifier. This method will fit one classifier per class against all other classes. I chose this method versus other ones for two reasons. The first being is that it's efficient since the number of models that we need to fit is only equal to the number of classes. The second reason is interpretability. We can glean insights on each class since it will only be represented by one classifier. Before I apply any models, I created a pipeline to be used for pre-processing and for modeling. I transformed the target by label encoding each genre and then creating bins for the genres. Next, I pre-processed the categorical columns and the continuous columns. For the categorical ones, I imputed missing variables with the mode and then used one-hot encoding. And for the continuous columns, I imputed missing values with the median and then used a standard scalar for all the values. Next, I dropped ID columns, such as track ID and song name. Since these are unique, they won't really help our model. Finally, I placed a dummy classifier in our pipeline that I will use to choose the most appropriate classifier for this problem. The two evaluation metrics I chose for this problem are F1 score and recall. I chose the F1 score because it balances recall and precision. In this setting, it's helpful to look at both. It's helpful to look at both. We want to see both the positive predictive value as well as the sensitivity. I also chose to look at recall independently, since we want to evaluate our model's ability to find the relevant genres for a song. To find our best model and best hyperparameters, I used a randomized search with cross-validation. Randomized search is similar to grid search, except it only looks at a random subset of hyperparameters rather than every single combination. For my models, I used the two candidate models I discussed, random forest and k-nearest neighbors, and I gave it candidates for the hyperparameters for the tuning. And through randomized search cross-validation, I was able to find the best model with its best hyperparameters for this problem. So the best model turned out to be random forest, and the best hyperparameters are on the screen with the max features criteria being square root, the number of estimators being 100, and the maximum leaves per node being 1000. Next, I looked at feature importance. For this, I used permutation feature importance. And as we can see, the three most important features are popularity, speechiness, and danceability. So in conclusion, yes, we can predict the genre of a song using audio features. And when I ran the model on our test data, I got an F1 score of 0.67 and a recall of 0.57. So, in summary, our research question was, can we predict a song's genre using audio features? To answer this, we created a pipeline that pre-processed our data and used a one versus rest classifier. To find our best model and its hyperparameters, we used a randomized search with cross-validation. And finally, we tested our model and we were able to get our scores. Thank you so much for listening.